Hi, my name is Adam Klinworth. This is my main course. It's on the How I Met Your Girlfriend video from DEFCON 18 by Samy Kamkar. And then he also did the Sammy Worm, and AntiSamy was because of the Sammy Worm. That's an OWASP project. So I'm going to be presenting on all three of those subjects. Just little snippets of each one. So here's an outline. I'm going to start out by doing How I Met Your Girlfriend, and there's three sections inside of that he went over each one of these in his talk to kind of come to the final kind of step, I guess. So there's PHP session seeding, which is an attack that he sort of created, kind of helped along with kind of breaking cookies and a random number generator with PHP sessions. And then there's NAT pinning, which is another attack that he kind of worked on and helped with a little bit. There's other variants of it as well that you might recognize it when we get to that section. And there's geolocation in there, which is it's pretty cool stuff. Still actually viable in today's architecture or today's world. And then I'm gonna look at the Sammy Worm. Kind of how it came about, the aftermath of it, etc. And then AntiSamy, which is, like I said, it's the kind of reaction to Sammy and the ways that we can prevent it from happening again on sites. So the How I Met Your Girlfriend video, it kind of the premise of the talk is to go from just wanting to be able to communicate with someone or kind of talk to them and get to know them, I guess, going from not knowing them at all to having complete access to them and knowing exactly where they live, so you can just walk up to their house and say hi. And he's using all these different attacks, like I said before, those three different kind of sections to get to that final destination. And I kind of mentioned it, but most of the attacks that he used and described, they don't actually work anymore. So the only one that does work is, at least on a consistent basis, is the geolocation. And for me, in my testing, that was only kind of half and half. So I mean, we'll see. I mean, I guess I'd like to hear from the people listening to this video, see what their kind of mileage was or is with that attack. So the PHP session seeding. Like I said, this one isn't viable anymore because PHP's patched it. So we're going to go kind of before this talk. So let's say it'd be like summer 2010-ish. So the sessions in PHP were made up of 160 bits. They included an IP address of the source, so that's the person actually making the request to the PHP server or the Apache server. The epoch, which is the seconds from January 1st, 1970. The microseconds that the user actually acquired the cookie, which, I mean, that's just like you can think of it as like a piece of the epoch. So, I mean, yeah, that's a pretty good description of it. And then a 64-bit random number, which is created from a couple different things, as we'll see later. And so the IP address is 32 bits, the epoch is 32 bits, the microseconds is 32 bits, and the random value is 64, which equals our 160, like I said before. So this slide is kind of, I mean, it's something that he talked about during the talk, but it's not really related to the information per se. But I thought it was really cool, so that's why I included it here. So I mean, it's kind of just some like tricks that you can do with bits. So if you have a 10-bit number, that's with all the bits are turned on. That's 1024, and that's 3 zeros. 20 bits is 1 million. That's 6 zeros. 30 bits, a billion. It's 9 zeros. So every 10 bits that you go up, you add 3 zeros. So that also means that our 160 bits here has 48 zeros. It's 16 times 3. So, and also, if you want to figure out like a number in between there to get an approximation, like you have your 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. you know those 0 through 9 pretty good. Or you can just say that, say you want 11 bits. You know that's going to be about 2,000. Or, like I said, like I have here on the slides, 15 bits is about 32,000. Yeah, and it's really kind of cool, and it's a useful thing to know. So anyway, here's our 160 bits, 160-bit values. I mean, that's a really big number. And I also have a approximately how long it would take to brute force this number, or brute force this number of combinations. Assuming we have 1 trillion passwords guesses per second, which is I mean, that's a pretty big leap over what we have currently right now. I think the fastest systems are maybe like 10, 15 billion, maybe. So I mean, this is actually faster than our kind of better or best password cracking systems right now. But anyway, it would take that number of millennia on the bottom there. I mean, that's impossible. I mean, it's not even feasible at all. So anyway, he kind of went through. We're gonna go through like reducing the number of bits that we need to guess, basically. So it reduces the total values that we have to guess at. So we know, like, the microseconds, which is 32 bits of our puzzle there. There's only 1 million microseconds in a second, which is less than 20 bits. So that reduces it by 12 bits right away. I mean, that's 12 bits that we know are always going to be off. They're always going to be zeros, so we don't even have to worry about those. So the IP address is our kind of our next section here. That one we can also completely reduce, because we can just do some social engineering or something and send the user that we're trying to attack to our server or wherever we're going, or wherever we want to send them, and just check the logs for where they connected from. And I mean, that's the whole 32 bits right there. And I have there. I mean, you can also just ask them for it. I mean, it's pretty well known that, I mean, some users are not that great, so they might just give their IP address right to you if you can trick them well enough. And there's also the epoch, which can also theoretically be completely eliminated, because in his example anyway, he used Facebook as an example where when a user logs on, it sends the server time to everyone. So therefore, I mean, since you have the server time, if you're watching for it, you can just throw that in there and you have the exact value that it's using to create the session cookie. So now we're on, at this point we have, at best we have, is that 76 bits eliminated? I mean, we're doing pretty good. I mean, that's a considerable amount, and it might be crackable at this point. Given, I mean, plenty of time, it's still going to take a long time, but we can do a little better. So the 64-bit random value that it uses uses a combination. It uses 32 bits of process ID and then 32 bits where it, I mean, generates some sort of other value. So the process ID side, in Linux anyway, all the process IDs are 15 bits long. So that instantly eliminates 17 bits for Linux. Like I think OS X uses 17 bits, and I'm not sure about Windows, but I mean, it varies, but he uses Linux because it's the best case scenario. And also, in a really good situation, you might be able to actually gain the process IDs. You might be able to use like run a PS or get some sort of error condition where you are able to see the process ID that the system's using. So therefore, I mean, then you know it right away, and you just eliminate all 32 bits that you have to guess at. Then the other 32 bits that are in that random value are it's an XOR of the epoch since the server seeded the random number generator, and then the microseconds as well since it was seeded. So, like the microseconds, we have the same issue as before where the microseconds are only 20 bits long, and since it's XOR together, you can pretty much just get rid of 12 bits since you know what they are. And we also know that the seed was, likely it was created, or likely it was seeded when the web server started. It was probably either created then or as soon as someone first requested the page. So depending on the server, it might have been within a few minutes, might have been a couple hours, but we still know it was probably within a pretty short time period. So at that point, part of the number of seconds, the epoch, is all, it's all static data as well within a certain time period. So if you know within, these had a 12-day period of when it was started, or when the epoch or the random number generator was seeded, you can guess the epoch with, or you can guess it with a relative level of assurance. But we still have 20 bits there. So at that point, we can theoretically get it down to 40 bits that we actually have to guess at. That at 40 bits, you can probably guess it because that's only about 1 trillion different combinations. But if you're sending them over at an actual server, it's probably not going to be possible to guess before somebody changes it, or it's just going to be too slow to send over the network. So he went on after that to say that you can guess the random, that 64-bit random value separately, and then combine it with the microseconds to have your final cookie. So you can, theoretically it would only be 21 bits then, since you're generating it and then combining it with the other side. So I guess, this is all in theory. I don't know if he actually did this against a real system. I don't think he did. I guess it's possible, but realistically it's really difficult, and it's probably not going to happen. And also the fact that PHP patched it. He said within a couple days they had a patch out for it, and that was before his talk even. So hopefully no one actually attacked this vulnerability. And 5.3.2 is the actual version that they patched it in. So that's so if you're running under that, you should probably go out and patch. Okay, so the next section is NAT pinning. So what this is, it's a way to open up a connection or open up a port from the external network. So from the internet, it would allow somebody on the internet, an attacker, to attack your internal machine without you port forwarding something or whatever you port forwarding or creating DMZ or whatever you're going to do. So basically what happens is you go out to a website. The website has a hidden form that's just like JavaScript. And that submits to port 6667, which is IRC. And that creates what's called a direct connection, DCC, for those familiar with IRC. And what that does is, what DCC is it tries to create a direct connection between two users. So completely getting rid of the IRC server. So what has to happen there is the person initiating the direct connection has to have a NAT rule in their router put in so that the person that's connecting to them is able to actually connect and communicate. So that's the basis of the attack, is you're connecting out, or you're creating a NAT rule so that somebody can come back into your network, except the fact that you weren't actually the one that initiated the request. You were just driving by a website essentially, and it made the request for you. And like I said, the key thing is that the connection itself from the browser. The browser is the thing that's actually making the connection out to a arbitrary IRC server. and the router just picks up that, hey, we see a direct connection attempt, we're going to forward this port to this machine so that someone else can connect. And then that allows the attacker to, say, attack Telnet or FTP or whatever on your machine, basically whatever port that they want to, whatever they put in there. So is it still possible? Theoretically, yes. I mean, it's still a perfectly viable attack. However, I'm not sure if the router was smart enough to tell that hey, this is an HTTP request, not an IRC request. I mean, it had IRC content in it, which the IRC server essentially, the IRC server just doesn't care about the HTTP stuff in there, and just looks at the IRC data. But the router might see that, hey, this is actually an HTTP request, we're going to block this, we're not going to actually open up this port. Or what likely is happening is the browser is saying that, hey, you shouldn't be connecting to port 6667 with a browser. I mean, you don't connect to an IRC server with a browser. You just don't. So that's kind of the likely scenario. And like I said, this didn't work for me. However, I did put together a little proof of concept. How do I get rid of this thing? There we go. Okay. So what's happening here is you just basically say that I want to open this port, and then obviously if that were a real attack, that would not be showing up there. It would just do it. And if you look at the source here, all that's happening is, and this was like the IP and stuff like that, that was created on server side before it actually got sent here, and it's just connecting to my IRC server, which isn't actually up, but it doesn't need to be. It doesn't matter, because it's just sending it to wherever, and the router just sees the connection and just goes with it. It doesn't actually have to have a response. It's creating a private message, direct connection, and then it just goes through, says, hey, connect to this server at this port, and then just goes. I mean, it just creates the connection and submits it. Unfortunately, like I said, it doesn't work on my particular setup. However, it might on different routers. I don't know. I only had the one to test with, so again, try on your own. Hopefully it works. Hopefully. So geolocation. This attack is kind of premised on the fact that Google is driving around with their nice little Street View vehicles, taking pictures of everything, making all these pretty things for us to look at. But they're also collecting packets and collecting wireless data as they're driving. And I mean, even if something's encrypted on your network or whatever, they can still see the MAC addresses. And they're saving the location of where they pick up these MAC addresses, and they're saving the signal strength. So it ends up being a triangulation, where as the car is moving like down your street, it sees that, hey, this particular location is the strongest signal for this wireless network. I'm going to say this is like 80% or whatever. And then it might move over a street, and at that same location on that street, it might be 65%. So they know that it's closer to the first street that they went down. And I mean, they're pinpointing locations of everyone's devices in the whole world. And I mean, it's a pretty cool concept, but it's kind of scary as well that, hey, you can figure out where somebody is in the world by their MAC address. So what? Why do we care? What happens is that services can query Google, their database, for like location data. Like if you ever go to a site that just knows where you are, like they might be using that database. They might be saying that, hey, this is your MAC address. We know your general location. Most sites though will ask you to basically give them your location, and that's always more accurate because the downfall, I guess, with this MAC address location is that if your device isn't there when the Google car goes by, or it's somewhere else, like you're at a friend's house or something like that, it'll show you as not, like your device won't actually be there, which is good and bad. But I guess the general idea here is that it's unreliable, because I mean there's just so many different factors that go in that might make you be somewhere else. The only thing that is somewhat reliable is that your router probably isn't going to move that often, so they can make a fairly decent guess about that. So the real kind of scary part is that we as users can also send queries to Google, because I mean it's just our browser that's querying them. So if we send a query of our own, it's going to look the exact same to them. So they're not going to try to like authenticate it or whatever. So we can ask them, we can give them a MAC address and say, hey, where is this MAC in the world? And they'll tell us. But the problem is, how do we get the MAC address? So there's two ways. In his talk, he went through a method with basically Ajax and some JavaScript where you can log into a router, and kind of the way of identifying routers and stuff like that. Like this page just kind of shows that a little bit. I happen to be running a D-Link router. Do whatever you want with that. So this page just has, this is just like a little proof of concept. It only has a couple iframes that just load in the background that they try to load a page that's of some router. And mine happens, once again, to be the D-Link. It was kind of weird when I was testing this. Firefox handles that pretty well and does what it's supposed to, more or less. But if I go over to Chrome and do the same test, it'll, like, all three of those pop-up windows will pop up multiple times, saying that I'm running all three kinds of routers. So again, kind of a weird difference between Firefox and Chrome. So the other way, I mean, after you get the address, or after you get the what type of router it is, I mean, you could go through after that and kind of log in with default credentials, because most people don't change those, and then just search through the right page and find the right page to get the MAC address, and then just send it to you through I mean, you can use the same method as before, just sending a request to your web server, and then just go check the logs. So there's either that method, or once again, you can just ask the user for the MAC address of the router, because again, they're probably just going to give it to you if you phrase it right. So with the MAC address in hand, we can then just go make a request to Google and ask, and they'll give you the latitude and longitude of the last known location for that MAC address. And I mean, it's very, very accurate. Samy he put a proof of concept out there. Let's see if I can find it. Right here. I don't have my MAC address. This one may or may not work. When I was testing it before, a couple days ago when I was testing this, it came up as me being in Austin, Texas. And as of today, it shows it like this, where now I'm just nowhere. And saying that it's I'll do that again. Yeah, so it's still the same thing. It says that it couldn't find my MAC address. So I'm not sure what happened in the last couple of days that messed it up, but something happened. He's also got a thing here where you can just basically just have location services enabled, and it'll tell you exactly where you are. So there I am. There's another, as I was looking into this, I also kind of thought of IP, like GeoIP, and how people use that to kind of tell approximately where you are. Unfortunately, I mean, this obviously isn't as accurate because IPs can change location because they're dynamic, obviously. And this shows me as being in Sioux Falls, whereas you see in the other one here, I'm in Madison. So yeah, good stuff. So, and then after all that was done, he kind of went on to say that, hey, we now have the person's exact location in the world, and we can just get Google Maps or something similar to give us turn-by-turn directions to their house. And he had an example of where he had a router that he had exploited and gotten the MAC address, turned it or sent a request into Google, and he was able to pinpoint the location of that router within a couple feet of where it actually was. That's pretty impressive. So now we're going to go on to the Samy worm. What was it? So it was a worm created by the same guy that did that talk, Samy Kamkar. It was released on October 4th, 2005 at about 12:34 a.m. He actually has it on his site, a nice little timetable of when he released it, how many users, etc., clicked on it, all that good stuff. It's pretty informative. So anyway, within 20 hours of the worm's release, he had 1 million compromises, which was approximately 1/35 of all the MySpace users. That's probably one of the better times for MySpace as well. Really though, I mean, this was realistically within about 15 hours because he released it at 12:30 a.m. Most people weren't online to click on profiles to go out and actually get infected. It took a really long time to really get it going and really see what it was doing. So anyway, here's the actual numbers that he gave on how many friend requests he had, which was how he figured out how many compromises there were. So after 8 hours, there was 222 friend requests. You can see he kind of kept going, kept rolling. Didn't really get going too far until 10 hours in. After that, it really kind of took off and was just ridiculous after that. I mean, between 13 and 18 hours, and that's when, that was the real power of the worm. He said after the 18 hours, just a couple minutes later, he was over 1 million. So, it really took off, and I have a feeling that if MySpace wouldn't have shut down, which is what they did, they shut down to remove the script from all the profiles, and of course they shut down his account and banned him and all that good stuff. It probably would have taken over every single user on MySpace, which would have been interesting in kind of a weird way. And like I said, it would have been faster if he would have released it at a better time because they were sleeping. So what did the worm actually do? It would add Samy as a friend on their profile. Then it would modify their user profile to include the text, and most of all, Samy is my hero. And from what I saw, it was under like the books, their liked books or whatever, and it just added that to the end of their text. And it would copy the code to their profile or their wall or whatever you want to call it, so that when someone else viewed the profile, they would also be attacked, and it would be copied there, and so on and so forth until everyone had it. And like I said, they made it exponential because as everyone clicked on it, that was another source, and it just kept going and going. And that's what made it so fast. So the actual code of it, there were some restrictions that MySpace had in place that made it kind of difficult to write. Like they were blacklisting certain terms, like they wouldn't allow expressions, they wouldn't allow him to write or to type in .inner HTML to get the full text of the page. And there were a couple other things too, where where it just made it kind of difficult to write. But he had some workarounds and got it to work. So, like I said, let's take a look at the actual code here. And I formatted this all nice and pretty so we can read it a little better. Okay, so like I said, the first thing that he had to work around was you couldn't actually just put in a script tag. So he had to put it as, like, it was just a URL essentially. And that just took it from like a style or CSS tag, and then just made it. Just made it JavaScript essentially, and it just doesn't eval and evaluates all the code in the code section here, in the expression I should say. And this entire, like, all the code is in that one expression, so that double quote there goes all the way to the end. And there were some single quotes. I think he couldn't. I thought he said single quotes he couldn't use. Not sure though. Anyway, so let's see. Here's an example of like not being able to use inner HTML, and how he combated that is he just broke it up. And pretty straightforward solution to that, and it worked really nice. So let's see what else we got here. Oh, there was an issue with like posting to the site itself, where he couldn't post if it was at a profile.myspace or like a subdomain. It had to be actually at MySpace. So what the heck? Let's just change it to MySpace in the code. I mean, it's fairly simple, pretty easy. This function was kind of weird. Like, this was in about the middle of the code, or it was right here. I'm not quite sure why he had that in there. I mean, it doesn't make any sense. I mean, it doesn't obviously do anything, so I don't know. The other thing that I noticed when I was looking over this code is he seems to be missing a lot of semicolons. Like, I'm not the best at JavaScript, so maybe you don't need all those. I mean, obviously, as we know, JavaScript kind of tries to correct what you're doing, so it would still run, but that just seems really floppy to me. Okay, so anyway, this code is out there. I mean, it's on his site. You can just grab it off there. It's on the Wikipedia page. It's on a lot of other places. And it's really easy to find and just grab. So I'm not going to go over all of it. But here's that one part that I said, but most of all, Samy is my hero. Just adds it in there, adds the div tags. Once again, they have to separate it out. Yeah. And also, let's see, what is that? So the aftermath. After MySpace came back online, which was approximately 2.5, 3 hours after they took it off, all the code was removed from all the profiles, but that phrase, but most of all, Samy is my hero, was still there on, I would say, I mean, it was probably on all of them. He only checked a few, obviously, but I don't see why they would just take it off a couple and not all of them. And, yeah. So to this day, that phrase can actually still be found. So if you go to Google, just type in myspace.com, Samy is my hero. I only got it on, you can see it on 26,000, 25,000. So, and if you just go to any of them, of course MySpace would be broken. Huh. Okay, here's one that works. Okay, here we go. But most of all, Samy is my hero. Kind of a interesting little calling card, but it's there and still here after almost 7 years, so that's pretty impressive. Alright, so AntiSamy. What is it? It's a library that was created in 2007 as kind of a reaction to Samy. And what it does is it sanitizes user input based on a whitelist that you create in an XML file. And it is obviously a policy created by the website creators that just kind of allows you to allow certain HTML tags. You might allow like a bold tag, an italics tag, H1 tag, or whatever, and then you want to just disallow everything else. So like I said, it's a whitelist. So all you have to say is that you want to allow those three, and then everything else is automatically disabled. And the library goes through, sanitizes, removes all the content, all the tags and content within the tags that's not pre-approved. So this allows sites like Facebook or I don't know, like WordPress or other like comment-based sites that allow HTML content like bolding to exist. I mean, it allows you to have those HTML tags without having someone just write in like a cross-site scripting attack or script tag or whatever, what might have you. I mean, it really enables that content without having the, I guess, the downsides or the vulnerabilities theoretically. So it's kind of limited though, because first it was written in Java and then it was ported to .NET, but it's never actually been created for PHP. They said that they had planned to, but they just kind of never got around to it. They suggest using HTML Purifier for PHP, which seems to be, I mean, a good method for sanitizing your input. And then the .NET version, like on their Google Code site, it hasn't actually been updated in over 2 years. And they also said that it's no longer being supported, no longer being updated. So, like if you're running .NET 4.0, .NET 4.5, it probably won't work right. So it kind of, again, makes it kind of sucky. So the Java version, which is, I mean, that's what they kind of specialized in or what they started doing. That one hasn't been updated in about a year. I think it was March when I looked. It also says that they have a Python version that's kind of in the works. That's going to come along, hopefully. But I mean, it might take a while again. So there is a demo for AntiSamy. I could not get one because, like I said, I'm running .NET 4.0 and it doesn't work. But they have a demo out there at antisamy.net, and it's just a form that allows you to just put in some sort of attack to attempt to do some cross-site scripting attack. So it allows you to do like bold tags, italics. I think underlines work as well. You can do breaks, but as soon as you do a script tag, it'll say that, hey, it allows you to do all this other stuff, didn't allow underlines. It's interesting, I didn't know that. And it tells you which ones got removed and why. Interesting though, apparently the underline, like, it removes the tag but allows the content to stay. So that's kind of interesting, which is pretty cool. And I guess, I couldn't obviously get anything to work, but not saying it's not bulletproof. So if anybody wants to go try it, have fun. And for .NET anyway, like there's libraries in place that assist with preventing cross-site scripting. So like anti-XSS, which is by Microsoft. So theoretically should be good, right? Like they keep that updated pretty well, and from what I read, with .NET 4.5 when that comes out officially, it'll actually be built into the language, and that'll be like the default encoder, essentially. So like it should, since it's default, it should actually prevent it relatively well, and hopefully we can get rid of cross-site scripting with .NET, hopefully. So that's all I got. Here's my references. I got a lot of it straight from source, and then the AntiSamy project from OWASP. So yeah, thank you much, guys.